So far we've talked about matrix algebra, talking about addition, we've talked about subtraction, we've talked about even multiplying times a scalar multiple, right? But now we want to look at multiplication with matrices. And the conditions for matrix multiplication is a bit more restrictive. So first, let's talk about what it is to be a row vector or a column vector. So a row vector is just a single row, a column vector is a single column. And we will define the product here to be this, R1 times C1 plus R2 times C2 plus Rn plus Cn, all those guys leading up to that. So for this product, you'll notice that we have the same number of terms in this row as we do the number of terms in the column. And that's very important for us. So when we start talking about doing matrix multiplication, right? So if we want to do A times matrix B. So if matrix A is an M by R matrix and matrix B is R by N, then we can do this product. And the result, this AB, is going to be a matrix that is an M by N matrix. So one of the big things we have to make sure of is that the number of columns in the first factor is equal to the number of rows in the second one. And so the product is going to be taking all of these, all the terms in the jth column here times all the columns, it's going to be taking all of the ith rows from A times all the jth columns in B, and we form each entry like that. So for example, if I want to do this product, it seems kind of crazy, but notice here that this first guy is a 3 by 4 matrix, and this other one is a 4 by 2 matrix. So because the number of columns in the first one matches the number of rows in the second one, then we can perform this product. All right, so let's actually write this out. We're going to need plenty of space here. Now, the result of this should be a 3 by 2 matrix, okay? So we've got to make sure that the columns of the first and the rows of the second are the same. When they are, the result is going to be 3 by 2. It's going to be those outer numbers there. All right. So let's make this happen. All right, so this is kind of what's going on in my mind whenever I'm processing this. We need to take this row and multiply it times that column to give us the first entry. So all of that's going to be one entry. So what I like to do is I like to imagine up to the side like this. I'm going to do 2, -1, -4, and 5. And I'm multiplying all of this times this column, 5, -7, -3, and 1. So I'm just multiplying all these guys straight across like that. So I guess when I first learned this, what I had in my mind was thinking, I'm going to take this first row, turn it vertically, and I'm going to say, I'm going to march you through town. I'm going to destroy everything by multiplication. So I'm going to take that column times everything in the first column. That's my first number. Then I multiply times everything in the second column. That's my second number. So I'm kind of setting it up. It's not really a matrix like this. This is how I envision that as I'm walking through. So 2 times 5 is going to be 10. Then we have plus 7. We have plus 12. And we have plus 5. So all of that, the sum of all of that is going to be my first entry. The next one is whenever I take that top row and I multiply times everything in this second column. All right, so let's see if we can track that in our head. So 2 times 4 is 8. -1 times 3 is -3. -4 times -2 is plus 8. 5 times 8 is 40. So, I mean, what you could do is kind of what I did over here to the side, and you can say, all right, let me multiply it times the next column like this, and that's how I get all of those answers. Well, the next thing I do is I'm going to take my next row, and I'm going to do the same thing. I'm going to march it through and destroy things along the way. I'm going to use that multiplication. So we're first going to be doing the multiple or the product of this row and this column. So negative 3 times 5 is negative 15. Negative 6 times negative 7 is negative 42. 2 times negative 3 is negative 6. 6 times 1 is 6. Now we'll move it on to the second column. So negative 3 times 4 is 12. Negative 6 times 3 is 18. 2 times negative 2 is negative 4. And 6 times 8 is 48. And then finally, we move on to the last row, and we're going to do the exact same thing. 0 times 5 is 0. 4 times negative 7 is negative 28. Negative 7 times negative 3 is plus 21. 3 times 1 is 3. And then we multiply that times everything in the second column. So 0 times 4 is still 0. 4 times 3 is 12. Negative 7 times negative 2 is 14. And 3 times 8 is 24. So once you have all of this done, you then add these guys together. So let's see, 10, 7, 12, and 5, 29, 34. We have 8 and 8 is 16, minus 3 is 13, so we get 53. And we just keep on doing that here. Let's see, these guys go away, so that's negative 57. Negative 16, 2, that's going to give me 50 here. 24, it's negative 4. 36, 40, 50. And that's how we do the product. Now you'll notice that if I wrote these in a different order, I wouldn't be able to do the operation. Because if I swap these around and I have the 4 by 2 first times something that was 3 by 4, because these guys aren't the same, I wouldn't actually be able to do that product. So you got to pay very close attention to that. All right, so in the next few videos, we're going to be talking about how multiplication is not commutative. So you got to pay very close attention to the order.